Mercury, the smallest and most elusive of the planets in our solar system, has long been a subject of fascination for scientists, astronomers, and curious minds alike. Situated closest to the Sun, it offers a unique and mysterious window into the early processes that shape the solar system. This tiny planet's proximity to the Sun creates extreme challenges for exploration, with conditions that are both inhospitable and extreme, making it one of the most difficult celestial bodies to study in detail. Yet, in recent years, Mercury has started to reveal some of its hidden secrets, thanks to groundbreaking space missions and advanced technology. One of the most puzzling aspects of Mercury is its sheer mystery. As the smallest planet in our solar system, it is sometimes overshadowed by the larger and more well-known planets like Earth, Mars, and Jupiter. Yet, it is precisely because of its size, location, and the extreme environment it inhabits that Mercury holds the potential to teach us profound lessons about the evolution of planets and the solar system. In the past, Mercury's behavior and characteristics were difficult to interpret, leaving many early astronomers in confusion. It was even thought to be a double planet at one point, and there was speculation about the existence of a fictitious planet called Vulcan, which was believed to exist between Mercury and the Sun. Over time, however, through the development of telescopes and more advanced methods of observation, astronomers began to peel back the layers of misunderstanding and glimpse the true nature of this strange, enigmatic planet. The first major step in understanding Mercury came in 1974 with the Mariner 10 mission, which made history as the first spacecraft to pass by and photograph Mercury. The images Mariner 10 returned were groundbreaking and provided the first close-up views of the planet's surface. This mission was able to capture images of about 45% of Mercury's surface, revealing a landscape that resembled Earth's moon, an ancient, cratered world. However, much of the planet remained unexplored, and researchers were left with more questions than answers. The surface of Mercury was an unfamiliar and harsh terrain that hinted at the planet's tumultuous past, and scientists knew that they had only scratched the surface in their understanding of Mercury's true nature. In 2004, a much more ambitious mission was launched by NASA in collaboration with the European Space Agency, ESA. The MESSENGER probe was designed to orbit Mercury and conduct extensive studies of the planet's surface, atmosphere, and magnetic field. It took MESSENGER over 7 years to reach Mercury, and upon arriving, it began its historic mission to unveil the planet's mysteries. This groundbreaking mission lasted more than 10 years, and during its time in orbit, MESSENGER collected a vast amount of data, including over 200,000 images. By the end of the mission in 2015, scientists had a much clearer and more detailed understanding of Mercury than ever before. For the first time, nearly the entire surface of Mercury was mapped, revealing an astonishingly varied landscape full of impact craters, volcanic features, and tectonic activity that had long remained hidden from view. Among the most astonishing findings was the discovery of an extremely hot region on the planet known as the Ravine of Fire. This hotspot, with temperatures reaching a blistering 427 degrees Celsius, is the hottest known region on Mercury. The temperatures are so extreme that they are almost unimaginable for us on Earth. The Ravine of Fire is thought to have been created by a massive impact that formed a gigantic crater measuring about 1,550 kilometers in diameter. The structure of this crater is unique because the heat trapped within it reflects the immense solar radiation that Mercury absorbs during its journey around the Sun. It's this process that results in such extreme temperatures. The minerals and rocks in the crater, along with the special conditions in the area, further amplify the Sun's radiation, creating one of the most intense heat sources in the entire solar system. Mercury is also home to another extraordinary geological feature known as Pantheon Phi, a vast structure consisting of radial trenches that radiate out from a central point. This feature was likely created by tectonic activity or by the cooling processes of the planet's core. The origin of Pantheon Phi remains a subject of debate among scientists, but it stands as one of the most fascinating landscapes on Mercury. This large, unique formation serves as a stark reminder that Mercury is far more than just a barren, lifeless rock orbiting the Sun. It tells the story of a planet that has experienced significant geological activity over billions of years, even though it remains one of the smallest and most distant planets from Earth. Another feature of Mercury's surface that stands out is its gigantic cliffs. One of the largest known is the Scarp, which stretches for more than 1,000 kilometers across Mercury's rugged terrain. This cliff is believed to be a result of the planet's core cooling and causing the planet to shrink over time. The immense size of the Scarp serves as a testament to the dramatic processes that have shaped Mercury, and it is one of the many clues that researchers have pieced together to understand the planet's complex past. Mercury's surface is also dotted with impact craters, some of which are vast and deep. One of the most well-known craters on the planet is the Rembrandt crater, which measures an impressive 716 kilometers in diameter. The central region of this crater is dominated by a ring of high peaks, which are believed to be of volcanic origin. These formations hint at Mercury's once active volcanic past, a time when the planet's surface was subject to intense upheaval and dynamic forces. Even though these volcanic features are no longer active today, they remain an important record of Mercury's geological history, providing valuable clues to scientists about the processes that have shaped not only Mercury but also the other inner planets of our solar system. In a surprising twist, Mercury has also been found to harbor traces of water ice in some of its permanently shadowed craters, particularly those located near the planet's poles. While it might seem utterly impossible for such a dry and extreme planet to contain water, this discovery has been a revelation for planetary scientists. Mercury's lack of a thick atmosphere and its close proximity to the Sun would seem to rule out the possibility of water. However, in the planet's deepest, coldest craters, the temperatures are low enough to allow water ice to exist. These permanently shadowed regions have remained untouched by the Sun's scorching rays for billions of years, providing a unique and stable environment where ice could accumulate. The discovery of these ice deposits has fueled speculation about the possibility that, in the distant past, Mercury may have had a more hospitable climate, perhaps even supporting liquid water in its history. Mercury's lack of an atmosphere, unlike Earth or Mars, presents a series of extreme environmental conditions that make life as we know it impossible. Its exosphere, a thin layer of atoms and molecules, is composed mostly of hydrogen, helium, oxygen, sodium, calcium, and potassium. This tenuous atmosphere is not capable of supporting life, as it lacks the protective qualities of a more substantial atmosphere. Mercury's atmosphere is so thin that the planet essentially has no weather systems or cloud formations. There are no winds, no rain, and no dynamic weather patterns like those seen on Earth. The conditions on Mercury remain relatively static, with the only significant changes coming from the day-night cycle and the extreme temperature fluctuations that result from its lack of a protective atmosphere. Another of Mercury's most fascinating features is its magnetic field. The planet has a weak magnetic field, which is only about 1% the strength of Earth's magnetic field. This magnetic field is generated by a dynamo effect, which is believed to occur in Mercury's partially molten iron core. This dynamo process, similar to that of Earth, produces a magnetic field that helps shield the planet from solar wind and cosmic radiation to some extent. While Mercury's magnetic field is much weaker than Earth's, it still serves to protect the planet from the Sun's intense radiation. This phenomenon has led scientists to consider the role of magnetic fields in the habitability of planets. While Mercury itself is unlikely to support life today, the existence of its magnetic field serves as a reminder that a planet's ability to generate and maintain a magnetic field can be critical in preserving conditions that could sustain life. Though it might seem counterintuitive given Mercury's proximity to the Sun, the planet is also home to extreme temperature variations. The daytime temperatures on Mercury soar to a staggering 427 degrees Celsius, but at night, the temperature plummets to a chilling -173 degrees Celsius. These extreme fluctuations occur because Mercury has such a thin atmosphere that it is unable to retain any heat. During the day, the planet absorbs an immense amount of solar energy, but without an atmosphere to trap that heat, it rapidly dissipates as soon as the sun sets. The result is a planet of extremes, where day and night bring radically different conditions. Standing on Mercury would be an experience unlike any other in the solar system. During the day, the sun would appear 3 times larger in the sky than it does on Earth, creating an almost blinding glare, while the nights would be pitch dark and cold. Mercury's orbital characteristics are another intriguing feature of the planet. Its orbit is highly elliptical, meaning that the distance from the Sun varies significantly throughout its year. At its closest point, known as perihelion, Mercury is only about 46 million kilometers away from the Sun. At its farthest point, known as aphelion, the planet is about 70 million kilometers away. This highly elliptical orbit results in variations in Mercury's temperature, with the Sun's energy reaching the planet more intensely when it is closer to the Sun and less intensely when it is farther away. A Mercury year, which is the time it takes to complete one orbit around the Sun, lasts just 88 Earth days. Interestingly, the planet's rotation is synchronized with its orbit in a phenomenon known as resonance. For every 2 orbits that Mercury completes around the Sun, it rotates 3 times on its axis. This results in a Mercury day, from one sunrise to the next, lasting 176 Earth days. Mercury's slow rotation and its unique orbital mechanics have led scientists to theorize about the future of the planet. Some astronomers predict that, over billions of years, Mercury's orbit could become more eccentric, potentially causing the planet to be drawn into the Sun as its gravitational forces push it inward. This scenario, though still far in the future, raises important questions about the long-term stability of planetary orbits and the ultimate fate of planets in the inner solar system. Despite the many challenges that Mercury poses for scientists, the continued exploration of the planet is crucial for understanding not only its history but also the broader processes that shape the solar system. In 2018, the European Space Agency, ESA, and Japan's space agency JAXA launched the Bepi-Colombo mission, named after the Italian scientist Giuseppe Colombo. This joint mission is set to provide a new level of insight into Mercury, with 2 spacecraft, the Mercury Planetary Orbiter and the MEO spacecraft, working together to study the planet in unprecedented detail. Bepi-Colombo is scheduled to arrive at Mercury in 2025, and its data will help scientists answer lingering questions about the planet's formation, its magnetic field, and its geological history. As we continue to explore Mercury, we are reminded that our solar system is full of surprises. Mercury may be small, but it holds profound lessons about the processes that shaped our solar system and the planets within it. With future missions like Bepi-Colombo, we are sure to learn even more about this fascinating, extreme world, uncovering the many secrets that lie hidden beneath its surface.